Welcome back. We are joined today by Theodore Postol, a professor of science, technology, and national security policy at MIT. He's an expert in nuclear weapons, delivery systems, missiles, missile defense, and has worked as an advisor at the Pentagon. So thank you again for coming back on. So we spoke after the US and Israel had launched its first surprise attack on Iran back in June of 2025. And at that point, you mentioned that the Iranians have probably nuclear material to build at least
Yes, they do.
10 nuclear weapons, and they're already a nuclear threshold state. So it almost seems foolish, as you argued then, not to develop a nuclear deterrent, given that the US and Israel will be back.
They don't even need to develop a nuclear deterrent. They have these materials. Let me just explain a bit, if it's okay, what they have. Let's talk about what they have, how they can use it, and then what it would look like if they retaliated after an attack by Israel, a nuclear attack on Tehran. I think given what we have so far seen with regard to Israeli and Iranian behavior, it's my guess that the first one to use nuclear weapons, if they are going to be used, will be the Israelis. They are far more reckless and aggressive than the Iranians have been. That's my guess. But the point that I think is important for all of your audience to understand, and I pray that there are many Israelis listening to this, is that an Israeli nuclear attack on Iran can be retaliated against. The Iranians will be able to do it even if they have not yet built nuclear weapons, because the time between going ahead and building those nuclear weapons, remember, I just showed you those tunnels, which are everywhere. And I'll show you equipment that could easily fit in those tunnels and be used. And it's my guess that there's a lot of equipment of this kind already in tunnels that may or may not have been used already to build a final nuclear weapon. But they don't have to have taken the final step. They could be following the edict of the Ayatollah Khomeini that they should not build nuclear weapons and just have this equipment sitting there, because the edict also says that if Iran is attacked and its existence is under doubt, is under threat, then it would be justified, according to this edict, to use nuclear weapons. So they are in a position, if they have this equipment, and they do have it. So let me just, shall I just take a minute or two and then I'll tell you what they can do, what the consequences of this would be. That's important as well. All right, so why should anyone understand that this that the Iranians almost certainly have the ability to build nuclear weapons? This is because they have this 60% enriched uranium hexafluoride. I'll show you what uranium hexafluoride is in these canisters. So here's a canister of uranium hexafluoride. It's got about 50 kilograms of uranium hexafluoride, and it's very rugged. It's maybe a meter in length, so it's not big. The total weight is about 100, is about 50 kilograms, 100 pounds. And it's got 25, 30 kilograms of uranium hexafluoride in it. That's enough to give you a nuclear weapon when you take the uranium hexafluoride and you convert it to uranium metal. All right, so how do we do that? Well, just to show you how large these containers are, here's 10 atomic bombs worth of uranium, 60% enriched uranium hexafluoride. That's about not quite 400 kilograms. They have 408 kilograms. So really they have 11 if you do a more careful arithmetic, they can make 11 atomic bombs with this material. Okay, this is for 90% enriched. These containers have 60% enriched, so you want to convert the 60% enriched uranium hexafluoride to 90%. Well, what you do is the reason it's uranium hexafluoride, which is a chemical substance, is because it's kind of crystal. The uranium hexafluoride is kind of a crystal. If this glass container contained a very small crystal, a small amount of uranium hexafluoride, only that, and its temperature was maybe 100 degrees Fahrenheit, 40 degrees Celsius, 50 degrees Celsius, that you would not see the crystal there. You would only see a clear container because it would be a gas. The uranium hexafluoride would be a dilute gas, a very thin gas. And the reason you want it as a thin gas is you're gonna put it into these what are called centrifuges. We're not going to worry about exactly how these centrifuges work. All we need to know is that the Iranians have these centrifuges and they know how to use them. That's all we need to know right now. And they have cascades of these. This is a particular cascade. We know this is a particular cascade of 174 centrifuges where the enriched uranium is put out, which could be 90% enriched. Now, you would need a few weeks of time with one of these cascades to enrich the 60% gaseous uranium hexafluoride to 90% enriched uranium. But it's still uranium hexafluoride. So I need to convert that to metal. Let's not worry about that. That'll give me, we won't worry about a critical mass. Let me just, all right, we'll worry about that. So what I would do is simply blow. I have a device. I have that's the size of a large closet that has that would be blowing very, very toxic high temperature gas, hydrogen fluoride, through particles, through a gas of uranium hexafluoride. So this is a very high temperature, very toxic materials. But you can build something that's feet in size to do this. You have a reaction chamber, high temperature hydrogen fluoride, high temperature uranium hexafluoride. What comes out is are small particles of a green material called uranium tetrafluoride, and that green material can be easily separated out with what's called a cyclone separator, so all the particles precipitate out. I take those particles, I put them into a container with lithium or calcium, and I heat the container up. It's a high pressure container. The chemical reaction occurs at some point. I get very high temp. So this is a very high pressure, but it's, can sit on my desk here. You wouldn't want, obviously you'd have some vacuum, but it's not something that, is a big facility. And then what you do is the metallic uranium precipitates out. It's heavier than the magnesium chloride or calcium chloride, and you have this. This is an ingot of uranium, 90% enriched uranium. All right, that's all doable in a tunnel. Of a few hundreds of square meters of floor space is all you need. A few hundreds of square meters. This is not a big action. You of course need baffles, but this is the kind of equipment, the Iranians already have this. Then you machine it. Now, to build a nuclear weapon, all you need to do is assemble. You have some way. This is a cartoon design. In this cartoon design, you have a a sphere of uranium-235, and you have 2 plugs of uranium-230 and a little bit of conventional explosives. Very easy to build. The conventional explosives drive these 2 sections. It's actually not to the right scale, but it doesn't matter. I mean, it's just a notional cartoon. Into this sphere, creating a critical mass. I have some material like beryllium and plutonium, which is going to generate neutrons. And this thing will go nuclear and give me a 15 kiloton yield. I don't need to test this. Let me repeat that. I do not need to test this weapon. This weapon never needs to be tested before I use it. So I can have 10 or 11 weapons without testing them that I can deliver with total confidence that they will work. I can test this device with uranium, with depleted uranium, to make sure that the assembly process works. So I make a few, and then once I have the device, I just assemble it with uranium, with 90% enriched uranium. No problem at all. The United States did this for Hiroshima. We never tested the Hiroshima bomb. We didn't bother. The bomb that was tested was the Nagasaki bomb, which was made of plutonium. The reasons you need plutonium you'd have to test is another story. I don't need to go into that now. All right. So let's again step back and say, well, okay, I have 10 or 11 of these weapons. I can build them. Within weeks. In fact, I can potentially build them in a shorter time than a week, because I may have multiple centrifuge cascades. One of these cascades could take 4 or 5 weeks to enrich the necessary amount of 60% enriched uranium hexafluoride to get 90%. But if I have 2 or 3 of these cascades, I can do it in a few weeks. There's no reason that they don't have several of these cascades. I mean, they've been building they've been building thousands of these centrifuges. We don't know how many of them they have stashed away. Everything wasn't necessarily in Isfahan and Fordo. We didn't have any numbers. Toward the end, when we the Americans broke the treaty, or the agreement we had to limit for Iran to limit its enrichment capability. When we broke that agreement, we lost the ability to monitor their construction of centrifuges. They said, okay, if you're taking away the agreement, we're not going to let you look at the. They let us for a long time watch the 60% enriched uranium, which they started to enrich after Donald Trump broke the agreement. And incidentally, Joe Biden shouldn't get off on this either, because Donald Trump broke the agreement. Biden became the president, and he didn't immediately reinstate the agreement. And I can tell you why. And that's important, because he's surrounded by these idiot Democrats. We talk about idiot Republicans. There's plenty of idiots and stupidity to go around in the U.S. National security community. And what these idiots were saying, we're now in a position to extract further concessions from the Iranians. So let's not give them back the treaty. Well, I don't need to tell you, you're a more studied person on these matters. You reach an agreement, you meet the terms of the agreement. You don't start rebargaining again. And Biden deserves a large amount of the negative credit for this disaster having occurred. It's not simply Trump. And I think all these interviews where you see like Jake Sullivan there, and he's saying, Trump did this. Well, let me tell you, Jake Sullivan was part of that. And these guys should not be allowed to get away with what they did. The Biden people are just as responsible for this disaster we're now facing. Anyways, sorry about my, I'll get off my stool now. Okay, so let me show you what a targeteer might do. And now I'm speaking from some significant experience here. I was involved in monitoring U.S. nuclear planning. I studied the plans. I was working, I had oversight responsibilities while I was working for the Chief of Naval Operations as an advisor. So I knew how we were using our nuclear. It wasn't some briefing that Jake Sullivan gets where he sees all these little pictures and we do this and we do that. And this is response 3. I know where the ground zeros go, unlike these idiots who claim to be experts. I know how you place the ground zeros. I saw the way we did it. Anyway, let me show you what an informed, well-informed, studied Iranian targeteer could do. First of all, you would want to do maximum damage, since the Israelis would have certainly killed a very large number of Iranian civilians. You are now totally justified in attacking Israeli civilians as well. They started it. They set the standard. You are retaliating. So that's my assumption here. I don't see any other assumption that you can have because, Anyway, what I've done is shown the fireballs of these nuclear detonations. They're they're hundreds of meters in diameter. This is a couple of kilometers, 1.5 or 2 kilometers in radius. So these are a few hundreds of meters in diameter. And inside this fireball, when the nuclear weapon detonates, these are low-yield weapons. They're not thermonuclear weapons. They're simple, simple weapons, so to speak. So within a second, within the 100th millionth of a second, an enormous amount of energy is released in a very small interval of time. And this little ball of uranium that has been assembled will just become a hot mass of material, and it'll be confined. It'll be a few meters in size for a few hundredths of millionths of seconds. And it'll be tens of millions of degrees in temperature, not hundreds of millions of degrees. If it's a thermonuclear weapon, it would be hotter. But tens of millions of degrees is hot enough. And what's going to happen is it's going to emit X-rays, which get absorbed by the surrounding air, and the surrounding air becomes superheated to maybe 1 million degrees. So it cools rapidly from 10 million degrees to 1 million degrees. And it's maybe 30 or 40 or 50 or 100 feet in diameter. So, because it's propagating out at the speed of light initially. Now that you have this superheated mass of air that violently starts to expand, because its density is that of the normal air, but its temperature is 1 million degrees. So this thing is going to violently expand outward, and it's going to act like a fast-moving piston on the surrounding air, which has no chance to move. So it gets piled up. So the air gets piled up as a shock wave at the edge of this fireball. So when the fireball reaches its maximum size at 1 second, its average temperature is dropped to about 8,000 degrees Kelvin. So it's about 2,000 degrees Kelvin hotter than the surface of the sun. But this is not 150 million kilometers away. This is kilometers away, fractions of kilometers away. So the light and heat radiated by this ball of light is tremendous. And because of that, it sets fires. And what this little yellow lines show is roughly the range at which fires will be set. So notice there are areas in between that I have intentionally allowed where the fire zone is not initiated, because I'm going to depend on the fires to do extreme damage and killing because my objective here is to maximize death and destruction with these 3 weapons. Remember, I have 8 others I could be using elsewhere in Israel. So here is what happens when the nuclear weapon detonates. This is the cloud from Nagasaki, and what you see is a rising cloud. This is white because this is condensing water vapor from the lower altitudes. You had a fireball created at lower altitude. It buoyantly rises. As it rises, it expands and cools. When it expands and cools, droplets of water are generated. And so it becomes like a cloud. Of course, it's very radioactive. It's tremendously radioactive. And look below here, you see the column of buoyantly rising hot air. This is just buoyancy. This is just Archimedes' principle. Sets up an airflow, and you can see that violently burning area below, which is creating soot, is following up this stem. There are fiercely burning fires below on the ground. The same is true. This is the Hiroshima bomb. Same thing, you see it. This is not unique. This idea that firestorms are unique to Nagasaki or Hiroshima, that's nonsense. That's for the Bulletin of the Atomic Scientists to talk about with their non-expert people. The reality is these create firestorms. So what happens? Well, let's look at a kilometer or so distance. Maybe a little bit over a kilometer and a quarter, something. Within a tenth of a second, if you have a structure, this is a wood frame structure, different structures respond differently, you would see the bright light of the fireball growing. That's 0.1 second, because the fireball is very hot, but it hasn't grown to its maximum size when it's brightest. It's brightest 1 second after it's the detonate. It's, of course, generated, the shock wave breaks away, but the shock wave is not yet reaching out to a kilometer or so range or so. And what happens is the front of this building is burning off. And of course, through the windows, ignitions are occurring. You know, the interior of the building is also being set on fire. About 10 or 11 seconds later, the shock wave reaches the building, and you can see the top of the building being crushed. Most people focus on the shock wave. This is what the shock wave envelops the building, crushes it, and causes tremendous damage. Now, the shock wave, of course, does extraordinary levels of damage, but it's wrong to focus on the shock wave in terms of the greatest danger, in terms of the killing from this nuclear detonation. It's wrong. It's the fire that kills people. And the fire is generated from combusting material. So here's a fire generated in Hamburg. This is 1943. And this fire is burning probably, this picture was taken probably about 40 or 45 minutes into the attack. These fires were generated by incendiary weapons. Not a nuclear weapon, but it doesn't matter. The fire I'll be talking about hereafter is initiated by the nuclear weapon. But the fire burns like any other vast area fire. But a vast area fire is different in character from the small fires you're used to seeing. Although the phenomenology is the same, but on a different scale. So the way this place was set on fire is they dropped munitions. Unlike what people mistakenly believe, this was intentionally done. This was not a mass fire. There were elaborate studies done on how many, what density of incendiaries you were going to drop, how many you were, because you wanted the incendiaries to drop between natural fire breaks. It would be natural fire breaks that would occur in terms of initializing the fires. So the Allies did statistical studies. This was not an accident. And also, they were not simply incendiary munitions drop. They were some of them were booby trapped. It's because if the incendiary came through your roof, which they were designed to do, they were designed to penetrate through the roofs to start fires in the interiors where they would burn and spread more rapidly. There were sometimes little bombs on them, so if someone in a room tried to pick up the incendiary and throw it out on the street, it would detonate and kill them. So this was very deeply and carefully thought out, just like this nuclear attack I'm talking about is deeply and carefully thought out. Spread the detonations out large enough so that not every part of the area is set on fire initially. This is death by careful analysis. So what happens then is the fires are most intense nearest where the fireball was illuminated. The fires are much less intense at the periphery, but they're initiated. They're, fires, your curtains are on fire. Everything in your apartment is not on fire, but the curtains are on fire. Maybe parts of the rugs are on fire. If there are books, or particularly if you have a desktop with paper on it, the paper's on fire. You're not involved in trying to knock out those fires. There's a blast wave that just came through that caused enough interior damage, shattering windows, knocking interior walls down. It may not have knocked exterior walls down. That you're badly shaken up. Family members are possibly injured or possibly injured. Some are burnt because the fireball is bright enough to burn their skin. You're not worried about putting out those fires. You're worried about trying to get out into the street, away from this horrifying level of damage inside your home. So this is a general area of uncountably large, like someone went around lighting matches and throwing lighting matches all over the place and just dropping them. The fires are not tremendously intense, but they're numerous locations, and nobody's dealing with them. So very quickly, the fires in the interior start causing air to buoyantly rise from the earth, because hot air buoyantly rises. And this buoyant rising of air leaves a low pressure area behind it. The air rises, it sucks, it has a sucking action, so air comes in from below. And since you have symmetry in the rising air, you have competition for the air in the center. So the net result is the air flow tends to flow inward. And the net result is that you get a fire burning over the entire area, because the buoyantly rising air sets everything on fire. So if you want to get a sense of the area that burns out, even though I had areas which were not initially set on fire, I set them on fire. Now, the benefit, I'm talking now in a ferocious, murderous sense. The benefit of this attack is I can set a significantly larger area on fire with the three weapons properly placed than I can do with individual weapons. So there's a great benefit to setting the fire, setting the weapons apart. I have the precision to deliver them that way. Now, in the case of these lower yield weapons, the radiation, the nuclear radiation from the fireball is intense out to about, it's significant enough just from the nuclear radiation occurs in the hundreds of millions of a second while this tremendous amount of energy is being released that eventually within 1 second creates the fireball. Well, then neutrons and gamma rays radiating out from that very small volume of air. Now, with bigger weapons, the neutron and radiation doses increase, if I have a much higher yield weapon, the range at which lethal neutron and gamma radiation goes out increases, but it's only slowly relative to blast and fire. So if it were a higher yield weapon, you wouldn't even bother talking about the lethal radiation from the prompt, what's called the prompt radiation, because you would be dead from the blast and the fire, the intense light and heat. But with the lower yield weapons, you're not necessarily immediately dead from these from the prompt radiation. So there'd be large numbers of people who are also exposed to the prompt radiation who would receive lethal doses at these ranges shown here, but sublethal doses at much longer ranges that would kill them within weeks if they didn't get killed in the fire. The chances are very good they would die in the fire. They would not escape. But if for some reason they happen to escape the fire zone, they're going to die weeks later from radiation exposure. And to make matters even worse, this shows you Hiroshima, and the scale here is kilometers. And this shows you an area of intense rain that occurred, rainfall, which was radioactive. Because what happens is you have smoke created by incomplete combustion of burning materials. And that incomplete combustion creates nucleation points for water to condense on. When the water condenses on it, other things are condensing on it. Hydrogen sulfide, which is another byproduct of fire. Nitrous oxides, these are poisonous materials. Cyanide, carbon monoxide, all of these really nasty things. And this dust, not dust, but these carbonaceous particles can get into your lungs. And it can be very efficiently deliver radioactive materials as well as toxic materials to your biological system. So if we look at where this radioactive rain fell, it could fall. I won't get it. Here's a region, I'm assuming a wind direction, where the radioactive rain from one detonation could fall. This would depend on weather. So it would depend on, if the wind happens to be blowing into the Mediterranean, the radioactive rain would blow there. But if the wind is blowing inland, it could be worse. You could, if you know the weather patterns well enough, land winds and sea winds are predictable. You could time your attack to make sure that the sea winds carry the radioactive rain inland. I mean, if you're in the business of spreading death and destruction because your people have been killed, I wouldn't put it past. Again, if I were in the mindset to be as murderous as I possibly can be, I would wait for a good sea wind. It's just a time of day, matter of time of day. And of course, I haven't had a chance to. The next time I give this lecture, I'll be able to show. Because it's so confusing. You can see that very large areas of Tel Aviv, in this case, downwind, would be subjected to radioactive rain following the nuclear attack. Many, many injuries would occur from exposure to that. Here is the horrifying image of a man who is dying from radiation exposure. What you're seeing here, this is probably weeks after he was exposed. So he was exposed to a lethal, but not immediately lethal dose of radiation. And what happens is your blood, the cells in your blood that are responsible for coagulation of the blood disappear. So your blood doesn't coagulate. So you become a hemophiliac, in essence. And what you also lose are the blood, the components of the blood that are responsible for fighting infection. So what happens is you die of massive infection and internal bleeding. So it's obviously not a pleasant way to go. So the net result is that a retaliation would be possible even if Iran does not now have nuclear weapons. And it's perfectly reasonable to expect this. So the message, I think, is important for people to get. And I'm talking about the Israeli political leadership. And perhaps more importantly, not just the Israeli political leadership, but more importantly, the Israeli people, who are not as crazy as this leadership is. They should understand that a nuclear attack on Iran would be answered with a nuclear response, that Iran is capable of responding, even though they have not necessarily yet built nuclear weapons. They have the means to do it. And getting destroyed 2 or 3 weeks later is no different in the end from an immediate response. So don't do it. Don't use nuclear weapons against Iran, because there will be death and destruction on the scale of millions of people on all sides. And it will just be horrendous. And just to give you a sense of the ferocity of these fires, let me just go on one more, a few more minutes to give you this is not a fire like the kinds of normal fires that you're used to. If you think of a fire from your experience with just a fireplace, Norway's a cold place. It's nice to have fires. You sit around the fire. There's usually a nice cool draft coming into the fireplace. Warm air is coming up the chimney, and everybody is nice and toasty. Well, if you have an area on ground on fire, and this area would be tens of square kilometers on the ground burning. So the buildings are burning. So this is a thin wafer. It's actually a thin wafer of combusting material. This is oversized in this diagram. But that thin wafer is very hot. In fact, the average air temperature in this thin wafer will reach above the boiling point of water. So you'll have air above the boiling point of water to heights several times the height of the highest buildings, because that's combustion is occurring at the building heights. The air velocities will be hurricane force, because this area that's rising, this volume of air that's rising is incredibly large volumes of air. For example, if I double the size of this area, if I double the size of this radius, the area that is being heated goes up by a factor of the square, 4. 3 times the radius goes up by a factor of 9 or 10. So since the radius, since the circumference is only going up linearly, the air has to go faster and faster and faster to keep feeding the so it's limited by the rate at which air can buoyantly rise and the scale of the area that's on fire. So you can imagine, so this is like being inside. Imagine you have a big area that you have set on fire, just with fires like fireplace fires, but it extends for 100 meters around you, and you're in the middle of it. And the air is just coming in and buoyantly rising, and the flames are around you. That's the environment you're in. And so you get these incredible drafts, macroscopic winds over kilometers, enormously high speed, hundreds of kilometers per hour, causing the fire. This is a fire over, I think, several tens of centimeters. This is actually an example, a setup. Here's over, fractions of a kilometer, a real fire. You can see the same behavior. We know how this happens. Here's an example of an experiment done with candles on a board. You can see how the fire was initially set as a ring. The ring, there was no fire in the beginning, but there was no place for the air to go in the interior, so the air just developed an inward direction, and the whole set of candles gets set on fire. This is an example of the kind of violent wind, and you get tornadoes that are generated from ground wind. The tornadoes are not generated from turbulence in the sky. They are generated from differential heating on the ground. So you have some area of ground that's burning more intensely than some other area. So it's rising more violently, and it's expanding more violently. So you get a rotating, it's like what's called a dust devil, but unbelievably high winds. Again, 100, 200 kilometers per hour winds. Temperatures, of course, are at boiling point, above the boiling point of water. And so what happens is when people try to run away and they're in the streets, you have phenomena like this. They just get burnt alive by the high temperature winds. And if they're in shelters, what happens is the shelters get extremely hot. So you're in a shelter, you're in Tel Aviv, you've gone down into the shelter. You to a very significant fraction of the people, if the shelters are strong enough, are not killed by blast, but there's a raging fire above them. This raging fire is going to go on for 5, 6, 7, 8 hours. Everything combustible is going to burn. Everything combustible is burning intensely, because just like you take a bellows and you heat coal with the bellows and it burns more violently, that's what's happening from these incoming winds. And everything, all the concrete, all the bricks get heated to very high temperatures. And what happens is the shelters get converted into ovens. And this is what you saw in places like Hamburg and Dresden in World War II. So this will be like nothing you could ever imagine, that people would ever imagine. And if you want to get a sense of what the streets look like, well, you might have many standing buildings. In Tel Aviv, a lot of buildings are high-rise buildings. Many of them will not be knocked down by the blast wave. These are low-yield nuclear weapons. They'll blow all the interiors of these buildings out. They'll set fires to everything inside them. But they may not knock down buildings that are a little bit further out from the actual detonation point. So you'll have scenes like this. And here, this is a scene from Hamburg. These were fire trucks that were abandoned. The streets were so hot, the asphalt melted. These firefighters escaped because they were at the edge of the fire zone. And they escaped by lying down next to the curbs on the street because the winds were so strong, and pulling themselves out of the fire zone because when the winds began, they realized they had to escape, and the hot air had not yet developed because fires were not yet burning everywhere. Otherwise, they would have been killed, incinerated in the fire. This is an example of what streets, you can see that these streets were covered with debris because the buildings were collapsing. So the fact that they were not knocked down nevertheless led to tremendous damage. So here's Nagasaki prior to the atomic bombing. Note the distances here are small. This is like 1 kilometer from here to here, less than a kilometer. What's good about this photo, though, is it gives you enough detail. The faraway photo wouldn't give you the detail. So here's what it looks like after. But this is, this would be maybe 2 or 3 square kilometers that you're looking at out of 25 or 30 square kilometers, all of which would look the same. So this is the level of damage you would see in a modern city. So, if anyone who thinks any Israeli political leader or member of the military, I want the military leaders to see this too and be aware of it, because I want the guy who gets told by Netanyahu to launch nuclear weapons against Iran to say, no, sir, I am not going to do something that leads to the destruction of Israel. That's what I want the Mossad members, the members of the Israeli Air Force, the members of the Israeli ground troops to know. I want them to know this. I want everyone in Israel to understand that this is what would happen if you attack Iran, because they will be able to put together nuclear weapons and respond. You will not get away with it, and the result will be the death of millions of people more than are already dead from your attack. So that's the message I want to send in this discussion.
Yeah, it's quite of a grim possibility, but it is also scary that we're actually heading in that direction.
I think people need to know this. Glenn, people need to know this. It can't be abstract. I put this together because I did not want it to be abstract. Oh, a few million people dead. That's an abstraction. I want them to see what a body on the street looks like of someone who's tried to escape, what the desiccated corpse of a person who's inside a shelter looks like. I want them to see this because that's the only way it becomes real. And I think the only way you're going to decrease the chances of something catastrophic like this happening is if people have an intestinal understanding, a real understanding of what would happen. And that's why I put together this talk. And anybody else who wants to hear it, let me know. I'll be giving it anywhere.
Well, thank you very much for putting together the material, and I couldn't agree more with you. The casualness of the whole thing, of how we're sleepwalking into such a disaster, it's quite shocking after all these years of carefully avoiding nuclear war, and this is where we're heading. So,
yes.
Do you have any final thoughts before we wrap up?
Well, I think the situation is serious. I think the war, from the point of view of the Israelis and the Americans, has already been lost. And that doesn't mean that Israel has to cease as a state. Israel can survive as a state, but it has to adopt a different attitude toward Iran. Israelis have to say, we have to live and let live. We don't have to agree with the Iranian system of government. We don't have to like them. We don't have to love them, but we need to respect their right to exist as a great nation. And unless we reach that understanding and we let them help them understand that we mean it, we're not going to turn again. We're not going to try another sneak attack. We're not going to make believe we're negotiating and attack them like we did to Hezbollah in Qatar, or like we did on February 28th. We cannot continue this way. We need to establish credibility as a negotiating state who acts according to the diplomatic rules that have been established since Ivan the Terrible was eventually, overtaken by civilization and diplomacy. You cannot continue operating this way. You are not the chosen people that you think you are. You are a people who have a great culture. You have great accomplishments. You have every reason to be proud of those accomplishments, but you have no right to be murderous in this way, and you have no right to disrespect the rights of other countries who also want to survive on their own. And you need to accept that, and you need to transmit that to the world, and in particular to Iranians, because right now, if I were Iranian, I would not believe a thing you're saying diplomatically. And if I don't believe it, I'm going to stay at the wheel and I'm going to continue these attacks. And it will eventually result in terrible damage to Israel beyond the terrible damage that has already occurred. And anyone who thinks that terrible damage has not occurred to Israel has been smoking banana peels, is just not understanding what this reality is. The economy of Israel is a shambles. And incidentally, I should say, as an American, and let me, I don't think of myself as an American Jew, but I do come from a Jewish background. I think of myself as an American, not as an American Jew. But I can tell you as an American, Americans are fed up with Israel. Israel does not have this relationship with the American population that it used to have. I talk to Americans all the time who say, I'm not going to war to defend those Israelis, and I'm not going to be sucked into a war to defend those Israelis. So Israelis who think that they're going to be on the gravy train after this thing happens, better think twice, because the American population is rethinking, and I mean the population. And I'm not only talking about Americans who are non-Jews, I'm talking about Americans who are Jews. And like I say, I do not think of myself as an American Jew. I think of my wife as a Catholic. I don't think of myself in these terms. But I can tell you that I know a lot of American Jews, and I'm not alone in the view that these guys in Israel have taken advantage of the United States, and I'm finished with them, and a lot of other Americans are. And they better think about that, because they have an economy that they have to rebuild. And the amount of help that they may be expecting to get is very unlikely to be what they've been getting in the past. That's my expectation.